I can see myself. Perfect. Sometimes this takes longer than a minute. It actually took an entire minute to start the live stream. Sorry, I'm a minute late. I can hear myself, I think. Yep, perfect. All right. Hey, everyone. Thanks for joining the live stream. If you're new here, welcome to the study group. If you're joining again, thanks for joining me on another Sunday. We meet every week to go through top Kaggle solutions. Today, we're going through the H&M Personalized Fashion Recommendations competition, and the goal for this one is if you are competing in the auto competition, OTTO that is. These two are somewhat similar. The H&M one was very recent. There's still about 2 weeks to go for auto. So if you haven't joined auto yet, maybe this gives you the motivation. And if you're competing already, maybe you'll find some golden nuggets. So I have one announcement before getting started. I'll be starting a study group on this book by Hugging Face. So we'll be learning about transformers and the Hugging Face API. This will start sometime in Feb, maybe the first or second week of Feb. So you don't have to do anything. I'll just keep live streaming it on the same channel. So if you're interested, just keep an eye out for that. Now I'll get started. For the first half of these live streams, I usually end up explaining the competition and sharing the context. And after that, we get into understanding the top solutions. So my goal for today is to let's look at the leaderboard. So my goal for today is to cover all of the goal solutions. And by the way, Guanshu Shu, who's a part of the H2AI team and usually wins competition with very few submissions, he's never shared his solution, but he gave me the permission to publish his solution. So you'll soon hear about it as well from me. Not in today's live stream, but I'll be sharing it very soon. If you don't know who Goncho is, he's an absolute legend and he wins competitions in very few submissions all the time. So now about this particular competition, the goal is to provide product recommendation based on previous purchases. They tell you what H&M is. I assume everyone knows that. Uh, and you're given a lot of different data formats to work with. Let me also point out one interesting fact about this data set. So you're also given images to work with. You're given a lot of product images. This is a write up by Andada. Mayank says hello. I'm doing great, Mayank. Great to see you. Um, so this is a write-up by Indada, and she outlines how the different product images are shared. So as you can see, these are images with very clean background, something that you would probably expect on a website. So maybe the H&M website has this. Usually, they also have people wearing these just to show off how it looks or stuff like that. But for this data set, it's very clean images. And you might assume that maybe this is a recommendation competition. Not many people would have used it, but the second position team did end up using this data. So now let's take a look at the most popular notebook, which also happens to be the EDA. Inside the data, you have the following CSVs or folders. So you have the images, which are images of every article ID. Articles contain detailed metadata of every article ID. Customers gives the metadata of every customer. And transaction train gives purchases with different details. What I'll do is, and what I'm trying to read here are the blue outlines. So inside the articles, the author says this table contains all H&M articles with details such as type of product, color, group, and other features. They pinpoint what exactly do you get in the metadata. So you can see there are some color information. So you could maybe assume, like, for my case, as you can see, the channel is orange. My name appears in orange. All these banners appear in orange. So maybe if I'm inclined to buying orange clothes, which I am, you could recommend those to me. Or you could probably do some form of clustering where you could see, oh, people like certain colors more. Or you could also possibly look at maybe younger people like brighter colors more, stuff like that. Alex says hello. Alex always joins his live stream, and I'm always always happy to see his name. And he usually joins them throughout the sessions, I think. So great to see you, Alex. 1729 says great work. Well, thanks for joining. So you can see that here are the metadata of different articles, and what other interesting features could be seen here. So you get the product code, different types of info. You get some garment information. So this could also potentially be useful. Like, let's say, um, my mother always suggests me to buy some form of cloth, which I don't remember. I'm sure every parent does. So maybe you should buy cotton clothes. So maybe it'll cluster cotton clothes and recommend those to you. Maybe it will recommend cotton clothes more in summer, something like that. You could also think of such heuristics. So the goal again for the host H&M is to improve their recommendation and make people buy more clothes so they make more money. And your goal as a competitor is to figure out how to help H&M make more money, which is to how can you recommend more products online which people will end up buying. So what I'm trying to suggest here as I go through the EDA is some ideas that you could think of. And then I'll actually point out what actually worked and the different baselines that were shared. Tarun says hi. Hello, Tarun. Tarun is also a regular in the live streams. Great to see you. So, some other EDA, ladies wear is the significant portion of all dresses. Sports wear has the least portion, and this data is also, I think, it's not for an entire year. It's for a few weeks. So, depending on the week, it might still vary, right? But this is the case for that. Um, the garments group by index, they say jersey fancy is the most frequent garment, especially for women and children. And the next number is accessories, and these are cheap accessories. Um, let's see what else is interesting in the CDA. They point out the different data sets or the different, sorry, different items of clothing that exist. So you can see garment upper body has blazer, blouse, bodysuit, cardigan, coat, all the expected stuff, and it's very detailed. It's a very large data set also in that sense. Um, you can see the information about number of products. So there are about 45,000 unique products, and you're supposed to select and recommend stuff from this. Inside customer, you can see their IDs. You can see if they're active or not, if they're a part of a club. So usually you end up signing for these rewards or these bonus benefits. People who sign up for these tend to be more loyal customers usually. So that could be another heuristic or feature. There is also fashion news frequency. Sometimes we end up signing for newsletters that we actually end up regretting and can never find the very small unsubscribe button. Or maybe you're actually actually excited about, I don't know, sneakers or stuff like that. So you actually end up signing up. This tells you if they have signed up for the newsletter or not. Their age and postal code. So I'll give a bit of a spoiler. The second position team actually realized that one strong feature was whether the clothes were available in a certain postal code or not. So even though this is for an online store, sometimes online stores don't deliver to a certain postal code. That was a very strong feature that gave them a nice boost, as they point out in the write up. Uh, which is also pointed out in this EDA that you have an abnormal number of customers in one postal code. The most common age for their online shoppers is 21 to 23, which is something you might expect, right? Like in the young adult age group, you might see more online shoppers. And a large number of the people are active for the signups. For the transactions dataset, you're provided with unique identifiers, all the unique transactions that are taking place. And you're also given the price of purchase. So I'll give one more interesting data point ahead of time. Hello to external awareness. The price varies for the same article. So for the exact same cloth, the price varies, and this was discovered sometime during the competition. This is because some discount or some sale is being run throughout the training data set's duration. So it could be possible that during the testing time, there could be some form of discount that might be running, or some form of promotion, which might be a thing to consider when you're creating a model for this. So like, don't be very strict on the exact price points, or don't just have that as a very strong feature, for example. Or you could also just use the average price of something. So let's say jackets go for 100 euros in summers and 50 euros in summer and 100 in winter. Just use 75 as a price point. Or you could do all sorts of interesting things. So that's one more thing to keep in mind. All right, I think this is all that's interesting enough in this data set. I don't know if many people have used the frequency, or like recommended based on how often do different products occur. There are also images, as I pointed out earlier, with very detailed metadata. So what this user has done is, they've plotted them by max and minimum price, and also given some subtext. So you can see that this says knee length shirt, dress in soft leather with collar, so on and so forth. So you also have this to work with. I'll give a bit of spoiler. So I was also curious how people will use this. One of the teams actually ended up using this inside embeddings. So what they did was they created embeddings of all the training images, and then based on similarity or cosine similarity, I think they clustered these into different groups and recommended stuff based on that. So that's how you can also use the image data if you were curious. So now for some baselines, I think the and let me remember to upload the notebook. I think the title should give it away, but let's also look at this notebook by Chris. Recommend items purchased together. So that's what he teaches you inside of this notebook, and he basically groups them together, and just the baseline is to recommend all of these together. Recommend last week's most popular items could also be another one. So these are all baselines or things to get started off. Of course, the final models are much more complex than this. This is also a form of clustering in this notebook. Customers who bought this frequently also buy this. So you're basically clustering frequently bought together clothes. Like, let's say, for example, Enrada points this out in some write up. I think it was in a discussion. So let me go to discussions real quick. So this is an example of movies, but you can understand where it's trying to point out. You could have two forms of users that have very similar profiles, that are buying very similar clothes or watching very similar movies. So you could suggest similar movies based on that. Or let's say one person is trying to build or bake, not build. I'm too in the roots now. You don't build pancakes, you bake pancakes or cook whatever. So let's say John is cooking pancakes and Jin is trying to buy the recipe for it. You will probably need flour, 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 flour for it. So what you end up doing is, this is another, as Chris pointed out in his kernel, this is one more item that's bought together with all of this stuff. So you could recommend this stuff, or you could recommend flour to Jane, and there's a high probability she'll end up buying it. Which, if H&M was selling food online, they would end up making more money on it. So now you have a baseline understanding of what we're trying to do. How this is evaluated is map 12. So you're trying to suggest 12 or order 12 items, um, that an customer can buy, and these are ordered based on preference. So you could have items less than 12, but since it's not doing any harm, it's a good idea to have all 12 predictions filled regardless. Nishchay is saying hello in the chat. Hey Nishchay. For some reason, the emoji isn't rendering, so I don't know what emojis you're using. I was contemplating if I should go to his profile again and mock him for the remaining solo code, but I decided against it in a second. All right. So here's how you do, or here's how you end up recommending all of this stuff. This notebook was shared in the forum somewhere, and it is by this user on GitHub. So the standard, or one of the standard approaches, is you have an item corpus which has millions of items. For our case, it's about 45,000, somewhere around that. You use the user history and context, or you use the context of what items are frequently bought together, or you cluster them based on color, or you cluster them based on season, or you cluster them based on age groups. You use some rules, some features, whatever, to generate candidates, and these are then ranked. So you use a LGBM ranker or something like that, and using that you end up ranking these, and that finally becomes the prediction that's fed to the model, or that becomes a prediction that is shown to a user. So here's another example where inside of an app you're trying to I don't know, maybe in this example they're trying to suggest apps for downloading. So I have an app corpus and there are different candidates that are generated. These are ranked, optimized, and then shown to the user for downloading. So whatever clothes end up getting ranked here, you could imagine that they are being recommended like so. So the user is most prone to click in one area usually, and that's where you'd like to have the best ranked cloth. It's also interesting. So like many people have different clicking patterns, right? Like I sometimes, some days I click in the top right corner, or I start browsing through there if I'm trying to buy something. Some people, I assume, they're always left to right. Some people are bottom left to upright. I don't know. um so maybe that's another heuristic some companies take into account. I'm sure they do, but I was just rambling on for a second. Shravan says hello. Hey Shravan, great to see you. Shravan is also an incredible Kagler. uh, Yep, that's the goal, to share the learnings for auto. So when I started the live stream, that's what I pointed out. Um, all right, that's all I wanted to point out from this notebook. And as you can see, many people joined and learned different things in this competition. Lorenzo says, "Thank you everyone for learning, helping me learn about LGBM ranker models." And this was one of the most popular ranking models used by a lot of people. Of course, there were ensembles by top teams, but this is what was the most widely used one, or the widely shared one. Um, how did that come about to be? So the different baselines, first of all, use that, and there was a baseline shared by Radek, which is on GitHub. You can go take a look from his write up. But that baseline, as I understand, teaches you how to create a LGBM ranker based model. How do you set up the CV for this competition? So you have about 105 weeks of training data to work with. Chris, of course, had shared a very nice way of setting up the CV. In one of the discussions, once I find it, it was somewhere. Trust me on that. I just saw it. I can't find it. But this user, clear and simple, very nice username and very apt because they visualized it in the correct fashion. So they say, let's look at the data like this. Instead of using dates, we'll use weeks. So here's a suggested way of setting up the CV based on Chris Diot's strategy. You have different folds where you use the last week for validation. Why do you do that? In this competition, your goal is to predict one last week, I think, worth of recommendations. So you would like to have it set up like so, where the last week of your training becomes your validation data point, and then it sort of helps your model learn about the future. future. So for different folds, to ensure there's no leakage, you could do it like so. So inside fold 0, you could have week 104 as the validation, and you only train until 103rd week, and then you keep reducing this by one. But if we're designing based on actual labels, why aren't we overfitting? They explain a few more details here and why it doesn't end up overfitting. So, long story short, you can definitely set up different folds, and to avoid overfitting, you just make sure the validation is the last week, first of all, because you're trying to predict the future, and you can reduce it by a week every time so that you have different folds. Different users also shared their approach of how they are using the data as validation. Pavel ended up finished second, and he said in his case, train features before 1st of April and move week by week until some week of September. And he says the ranking model didn't need much data. And for example, to train the ranking model, he used only the labels generated from last 5 months. So you also have to look about where is this useful. And I didn't point this comment out randomly. I wanted to move the discussion towards memory trick. So when you're using so many thousands of columns, sometimes even potentially millions of columns, you start running out of memory really fast. So for example, in the auto competition, uh, you would struggle if you were working under under 150 gigs of RAM or some crazy amount like that. And as the data gets larger, you would definitely need more and more RAM. So it's worth finding out how much of the features or how much of the candidates are helpful, and it's worth looking into which actually are good enough for the model. You could have some very marginal gain. Is it worth it? Sometimes not. So it's worth evaluating, and for that you first of all need a CV. So now that we have a CV, how do we optimize all of this? Chris shares this discussion. He says reduce memory 8 times or 16 times, which means you can iterate 16 times faster, proportionately faster. Basically, if you look at this function, what he's doing is you're applying all of these as integer 64, or you're converting these, I assume, from float 64, float 32 to int 64. And similarly, you can go through different columns based on their requirements. You could convert them into int 32, string, or int 8, depending on what data they're storing. And you need to make sure that you're not doing any lossful conversions. I think lossful isn't a term. So you don't want to lose any data while converting the columns. Let's say if you're going from int 32 to string, for the example we saw, it is actually a string. So you don't end up losing any data. You convert to int 8 for date time, which actually is a date column. Where did I see it? I'm trying to find the column I was talking about, but I think I lost track. It was daytime somewhere. And I lost it. But anyways, you want to make sure you're not losing any info while doing this. So once you have the CV set up, you also need to make sure you're using as less memory as possible. You're not running out of memory all the time. So that was another trick shared in this competition. Um, we've looked at the images. There are different recall methods available. So Poteman pointed out that there was popular articles recently. So by articles, he mean clothes bought recently that were popular. The articles which the customer bought in history. So there's a high chance if you bought some clothes, you might end up buying something similar or maybe some piece of article again. There's also item CF and user CF, which will come up later as you go through the top solutions. Um, he also says there's price popular, calculate the mean price of user and get the most popular item in every price bin. So this is really cool. We're going one step beyond pricing. So you usually, I don't like spending any money on clothes. I like spending all my money on GPUs. But let's say you're always buying shirts worth 20 euros. So Potemkin is suggesting you group all shirts that are very popular in that price range or right around that, and you end up recommending that to the user. So these were some recall methods that you could have used. Um, this particular user also scraped, as you would expect on Kaggle, people try to reverse engineer a lot of stuff. They scraped H&M's online shop and then arrived at the result that this was from Netherlands. So H&M has different websites for different countries. I think their conclusion in this research was uh, this particular website is from Netherlands. Here's the paragraph that I was looking for. And they did a lot of research to make sure the facts line up, and they found out the sales or the discounts that were running and different details around that. So now let's take a look at how everyone also got started through this competition. So Pavel had shared this. This was the most popular, I think, discussion in this competition, and he had said addressing common questions and what is the competition really about. He says to simplify, he calls a set of articles that a customer bought on a given date a basket. So cart or basket. I see a discussion. I was trying to read that. Sorry, I'll just come to that, Leo, in a second. Um, and the general approach for such problem could be for each customer, generate candidates that they can buy. And these candidates are your negative and positive example. Many people also did negative downsampling. So that means you delete the negative samples or samples that people don't end up buying, and that is also sometimes common in such competitions. So negative downsampling by definition means reducing the signal of something. For such cases it means removing the data examples. Negative downsampling means removing the negative examples, if you didn't know the definition. I feel like sometimes this could also be good interview questions. I don't know, maybe people don't ask such questions in interviews. Maybe they just make you write on whiteboards and stuff like that. Okay, back to the competition. For each customer, we're generating candidates that they can buy. These candidates are your not negative and positive examples. So stuff that they buy and sometimes they do that they don't buy. And he clarifies, because someone on the forum was discussing how do you come up with negative observations. The answer is you generate them. The strategy to generate the candidates generally is the most important strategy. So you could do this based on item to item similarity between customers' previous purchases. So you could use image similarity. Powell actually ended up using that. You could have user-based collaborative filtering. We just saw how that could be an approach in Andada's write-up. You could have the previous basket. So let's say if someone is buying, I don't know, handkerchiefs every few weeks, they might buy them again. So you could probably suggest that. And it could also be model based predictions with customers without the transaction history. So you could have a model predict stuff for them. He already predicted that there won't just be one strategy, there'll be multiple of these. Once you have all the strategies ready, it is time to create a huge table with columns like these. So you could have the observation date, customer ID, article ID, bought in the next week. This is the label that you're trying to predict. Some static attributes, some dynamic attributes. The same for articles and customers, and whether the article exists in the strategies and which ones, and the score of the strategy. Then you build a ranking model that ranks these items within a customer. So the most popular one was LGBM ranker, and it is quite straightforward. You can read the docs if you want. But now you have all of these candidates, and you'd like to rank them and suggest them to the customer. So that's what you end up doing. He also gave some general tips. You should sample the data as much as possible. Um, and you should test different ideas quickly, which is always key for any competition for that matter. So now we have the complete context that at least I wanted to get across for this competition. Let's start going through the top solutions. Here's the leaderboard, and we can take a look at the best score. So the best score is about 0.037. Higher is better. And there's very slight difference in the top two teams. There are larger differences as you go down the leaderboard. Let's scroll a bit to see. So let's see. Gold is about 0.33. And I'm pointing this out because when you read the write ups, people just point their scores and CV scores out. So 0.33 and above is roughly gold. And wow, this is what I was pointing out earlier. Guanshu ends up winning with just nine submissions. So he he ended up in the gold with just nine submissions, and that's usually how he goes. Um, anyways, coming to the top solution, now I'll go through these in order. And let me actually get to the comment I was looking at. So Leo says, hello, he's going back to the beginning, still haven't finished the deep learning book. You're welcome to join any of the live streams still. So I try to keep this independent. So whatever is of your interest, you're welcome to join that, Leo. Cool. First place solution. This was by Senkin, and his teammate was. I zoomed in too much. His teammate has a very cryptic username, and this is their username. So if you want to find them, you could also connect with them on Twitter if you want. But Senkin and their cryptic username teammate had won the first position. Here's the overview of this solution. The most interesting part, they say, is to generate, train, and test by ourselves. The candidate generation strategy is key to beyond limitation of accuracy. Good feature engineering or modeling could be close to limitation. Their solution uses various retrieval strategies plus feature engineering plus gradient boosted decision trees, which according to them seem powerful. Here's a visual overview. I'll come back to the write up. But you have all of these are candidates. Previously purchased items are the candidates. You use different retrieval strategies, and based on that, you come up with 100 to 500 uh, top candidates. These could be repurchases, these could be based on item CF, these could be items of same product code, popularity. You could use graph embedding, and you could use logistic regression with categorical information. I'm not too clear about the last one. Maybe they're the only ones who ended up using this. So I'm trying to understand this as I read. I guess they're just like trying to predict categories of top end candidates, and then you rank these using the following 12 models. So 5 light GBM classifier and 7 cat boost classifiers. Let's read the text. They mainly generated recent popular items because fashion changes fast and is usually seasonal. They also tried to add cold start items, but they will be never ranked top 12 due to the lack of interactive information. So cold start is a very cool concept. Let me quickly introduce that if you're not aware of it. I'm a new user. I want to buy clothes. You are H&M. You want to sell me clothes, and you want to sell them based on clothes that I have been buying. But I am a new user. So how do you recommend this stuff to me? That is the cold start problem. That you need some data in order to predict some data. And how do you end up getting around that? Netflix, if you have observed, makes you tell that, hey, I like this movie, I like this genre of movies, this is a movie I enjoyed, this is a movie I did not enjoy. Same for YouTube in many ways. That's how they solve the cold start problem. YouTube, if you just create a new account, I understand it just shows what's popular in your region, and then I think it's one of the best recommendations algorithm because it gets very custom to what you are viewing. The cold start problem, in summary, is when you don't have any data to recommend stuff to people. And this is cool that For such problems, they'll never be recommended because there's a lack of information. He says user and item interaction information are always the most important of recommendation. The features that they created are almost interaction features. Image and text features didn't help much. Almost 50% users have no transaction. So they created many cumulative features for them and the last week, month, and last season feature for active user. So by this, I assume they mean what were they doing in the last week, if they were purchasing some stuff in the last month. And seasonality also matters for fashion, which means that in summers you're bound to buy some types of clothes, in winters you're bound to buy something else. That's how this works usually. They use 6 weeks of data as training, the last week as validation, and retrieved 100 candidates for each user. They focused on improving single LGBM model to the last week, and their CV at that time was 0.04 and the LB was 0.36. So the single model wouldn't have gotten them to gold. I assume they ensembled all of this, which gave them the final push. For candidate generation, they say they focus on increasing the hit number of retrieved 100 candidates by trying various strategies, and they've shared the hit numbers for different weeks here. For ranking, they also share feature engineering tricks that they had used. Features are created based on retrieval strategies, and they create user item interaction for repurchase, collaborative filtering for item CF, create similarity for embedding retrieval, and item count for popularity. So you could have count based features for how many times are these being bought. You could have time based features, so last days of transaction. You could also take the aggregates of price, sale, age, and you could also take the ratio features, like so, where you could have the difference between age and mean age of who purchased the item, and the ratio of one user's purchase item count and the items count, which means how much did one user purchase the item versus how many times was the item actually purchased throughout their website. You could also do some collaborative filtering or cosine similarity based recommendation using word to vec. So they actually did some negative downsampling, as I pointed out earlier. They had retrieved 100 to 500 candidates for each user. The negative sample number is very big. So they found 1 million to 2 million negative samples for each week had better performance. So that's the number that they ended up downsampling to. Next, they share the scores for LB and CV for different candidates. Their best model appears to be, all of these are very close, which is interesting. But for 500 candidates with 20 weeks seems to be the best candidate. Sorry, the best the best model. They talk about optimization. So they had used Treelight, which I had never heard of before this, to accelerate the inference speed. And Cat Boost is 30 times faster than Light GBM CPU inference. I point these facts out because for me and maybe for you, if I assume anyone who actually does this a lot would have this intuition, but it's also good to remember, okay, next time maybe you're trying something on Light GPM and that's taking 4 days to infer. Well, first of all, you have different problems because then the data is too large. But anyways, let's say that's happening. You could try Tree Light, and you could maybe also try switching to Cat Boost in that case. So that's why I always point such facts out. They also transformed all categorical features uh, to label encoding and reduced memory usage. I assume they'd use the function that Chris had pointed out. They had created a feature store and saved intermediate features to dictionary. So someone had asked what they meant by this, and I'll just show that. And apart from that, they had also split all users to 28 groups and run inference with multiple servers. This is very cool. So let me break this down. There were quite a few users. So let's say there were 1,000 users, and let's say the combined inference is taking a week. You could spin up um, the cheaper instances, the preemptible ones. I think that's what they're called. So what they actually ended up doing was, they, let's say you had 1,000 users, they divided those into four sections, so 250 each, and then ran inference of all of these, and towards the end they would have combined these into one CSV. So instead of waiting 1 week potentially to get the results, they would have waited about 2 days with this approach. So that's one way of speeding up your inference. Now let's take a look at what a feature store is. um, it was somewhere. All right, here it is. uh, yeah, so the idea is, instead of recalculating the features every time, you can just create a feature store. So you just save them as a Parquet file or something like that, and you just end up feeding that to the model. So that's what the feature store is referring to. These were the different speed up strategies that they had shared. But to summarize, they generate about 100 to 500 candidates, do a lot of negative downsampling, use 12 different models, do a lot of optimizations there, and then they end up with the best scoring model for this competition. So remember to upload this, and now we can move on to the second place solution. Also, this user, I'm laughing because their username is funny, but oh, sorry about that. This user, I think they became a grandmaster through this competition. So congrats to them in hindsight. But Pavel, the person who had shared a lot during this competition, and this user won the second place solution. So let's take a read through their solution. It's a combination of both of their perspectives. So we'll first read about the author's perspective. I was trying to figure out if I should call their username something, but let's not go there. He says he didn't do a good job of recalling product candidates. At the beginning, he tried recalling such by using item CF, but later found the effect was not even as good as directly selecting popular products. So item CF for this use case wasn't good. The solution was to directly select about 600 most popular products for each user, and then train a LGBA model to select 130 candidates for each user, and then add all products purchased by the user in the history as final candidate. After that, train another LGB model to get the final result. Compare these models in recall stage, and then the feature will be more complex. Features can mainly be divided into groups. So these are basic features that include number of purchases, price, sales channel, etc. Could have product basic features, so statistic based on times, price, age. They're calling this basic features. You could have combination features, so statistic based on each attribute of product, including number, times, time of sale, I think, sales channel ID, and last purchase time. You could have the age product combination features, product popularity under each age group, and you could have user product repurchase feature, whether user would repurchase a particular product or not. So they also used item CF features, which they said didn't help a lot, but I think it to the final solution, made it to the final solution. Calculate the similarity of each item through item CF, and then evaluate the score whether the user would buy this or not. The score of their single model was about 355, and after adding his teammates' candidates, it got to 362, which I think is in the gold range, right? We just looked at that. Oh, sorry. Also to point out, the first position teams models also were in gold. Looks like it. Let me go back and verify that, because I don't want to. I said they weren't, but it looks like it is. So their base model was about 367. Yes, their individual models were also in the gold. All right. Sorry about not giving the proper credit there. All of their models were by themselves also in the gold, but ensembling them made it to the top. And the same is true for second team as well. So Powell's candidate strategies. Let's take a look at that. He had used all sorts of counters to measure popularity of items in different groups. Customer attributes, different combinations. He says the most important one was postal code. And for article attributes, different combinations and then intersect with customer history. So if a customer bought an item, he would look he would then look for other popular items with similar properties. He'd also use, so this was the first time I saw someone using image similarity. And it's really cool because no other team actually ended up using this, right? So even like a model like MobileNet, which is definitely is not the most popular one, is a very lightweight model, was used here. So you could use that for image similarities. He'd use co-occurrences, so inside basket and outside, and then he did a random graph walk over user item graph. So he, I assume, would have constructed a graph of item and user purchases and did a graph walk or graph traversal, refer to the same thing. Other features were customer or article attributes and all sorts of similarity based on based measures. For example, average similarity of items versus the items the customer bought. And there was also streaks, which is a very cool feature. So many article attributes, he calculated the streaks measuring the number of times the customer bought a product. This ended up with 1,000 candidates per customer, and using some clever tricks which aren't shared here, they got to a very high score. For modeling, he managed to write a lambda rank map for LGBM ranker, mostly by copying code from XGBoost. So I'm not sure what this is, but I assume it's a feature inside of XGBoost which they ported to LGBM ranker. And this was slightly better than lambda rank. He says for the whole competition, they trained models using 2-3 months of transaction and last weeks to validate. Deep learning models weren't effective for them. How to improve competitions like this, he says. A large part of the competition was about predicting the availability of products. This was disguised as a recommendation. He, he suggests that you should provide the state of articles if they're available or not. And to minimize the calculation, he suggested to provide a list of customers with transactions in submission week. All right. The discussion was very dense as well, but there's not anything worth pointing out. So this was the second place solution. To summarize, they did a lot of interesting feature engineering, and both the teammates did a lot of different candidate generation strategies, which combined together got them to the second position. Um, I don't think I missed anything else from here, so that's all. Someone is asking how to collaborate with me. For the live streams, you mean? You can reach out to me anywhere if you'd like. The third place solution, let's read through this. And this is a solo goal for Sirius. That's the name, Sirius. But they talk they talk funnily about he must thank the pandemic that kept him isolated for 2 months and forced him to focus on the competition because there was no other thing to do. And basically he won $8,000 because of that. And he says the learning was even much more than that. Uh, cool way to see how some legends utilize their time. But anyways, let's read the solution. His pipeline is very similar to others: candidate generation plus ranking. That's why I spent a lot of time explaining what that is, because now it's easy to just say, hey, candidate generation, you all know what that is. I can wave my hands. He said he noticed most part of the solution, either the recall methods, has been used and described. So he will briefly introduce something different and useful in his case. Features about recall strategy: whether the article is recalled by strategy name and the rank of this article under the strategy name, so it could be items here for whatever, because he ordered the candidates under recall strategy by some metric, the rank number can reflect the relevance. These features plus an expansion of candidate number boosted his score. So he was generating candidates, or he was applying all of these approaches to rank these. He also created a metadata about what model he was using to generate those features, which changed the color of medal from silver to near gold. He says that's very cool to see. Um, BPR matrix factorization. The similarity of user and article is important for ranking. Features about item to item similarity, such as count of number of times they're bought together or word to wick, are commonly used, and these also boosted his score a lot. But what improved his model most of the times was user to item similarity obtained from BPR matrix factorization. For the recall, he had used the most popular items that the user had recently purchased, popularity based on the user attributes, so what someone in their age group, gender, etc., would like to buy. Items which have the same product name, or items which are similar to what the user has recently bought. He had also used downsampling, and he kept the negative samples about 30 into length of 30 times the positive samples. The positive samples are the only ones which are recalled in the candidates, and the other items are not included. Some more details about the features. So counts of user item and user item attributes in last 7 days, 30 days on all transaction. Day difference of user item and user item attributes. Similarity using BPR, word to wick, Jacquard, text and image similarity. So this was another competitor who used the image similarity. Item popularity and features about recall strategy. It used just three uh, different types of model, and the final version was an average score of 16 models trained with different hyperparameters. So that's the third place solution, using some different features. So adding some features based on similarities, and also a few more ones we saw. Plus, having this matrix factorization was the key difference we see in this solution. At least that's my understanding. So this was the third place solo gold solution. Let's move on to the fourth. I don't see anything in the chat, so we'll keep going through this. I'll remember to upload this. This is the overview of the pipeline. First, generate candidates using different recall methods. Build a ranking model that ranks candidates within the customer. So he had used all of these recall models and come up with these models. Then he used two ranking models, light GBM, and I think this is a convolutional network. Based on that, you get top 12 models. The CV setup was what we saw earlier. So for the recall models, he had developed four in total. Item to item collaborative filtering, the relationship between pair of items, the user who bought Y also bought Z, for example, if the item was repurchased, if they were popular, and two tower MMOE. He says he mainly focused on improving the performance of this model because it can generate candidates of any length for all users. And the user item embedding can also be found as used as an important feature. He had used a gating network to make sure the user tower can learn well by using different exports for recent active and non-active customers. And this is the overview of the model. So this is the first time we see anything very close to deep learning at all. There was an embedding of the different features being fed into a deep layer, and you can see that there's a gating network and a time embedding with different exports. So exports are, I assume, models being used to generate user embeddings. And as you can see, he's also applying attention to all of these models. Sorry, I didn't mean to school. But this is a part of the two-tower MMOE model. So with that, you get the final user embedding. For the ranking model, he says the Mainly used, he had used light GBM with lambda rank objective. He had also implemented DCN. So DCN is not deep convolutional network, I assume. Improve deep and cross network with practical lessons for web scale learning to rank systems. Sorry about that. I assumed it's convolutional network. That is not the case. It is deep and cross network, and the paper is linked in his write up if you want to check it out. He said the score of light GPM is much better. So one thing we've of course seen so far is that light GPM is the model ruling everywhere. For cold start problem, the two tower MMOE can generate candidates using demographic features without purchase lag. And to solve that, besides product meta features, it also extracted features from text and images. So it performed TF-IDF features from product description and clustered based on SVD and k-means. And for images, he had extracted image vectors using efficient net. So even though this person had used something stronger than mobile net compared to the second position, because of the other factors, they were slightly lower in the leaderboard. It's cool to see that some teams definitely used images in this competition. I think they've shared the notebook for their final inference. No, this notebook points out to a tutorial by Jiba on how to ensemble. So this was all for the solution. There are some discussions here about MMOE, but that's all I wanted to point out from this one. Let's keep going through the other solutions. We will go about 10 minutes over the hour. I hope that's okay with everyone watching live. Let's take a look at the fifth place solution. So I'll remember to upload this. He says his teammate is a huge fan of online shopping, which gives us a lot of help. And he had another friend who didn't even join the competition, so he's giving a shout out to them. Overall, he says he loved the competition so much because it did provide infinite ways to solve the problem, especially with the recall methods, and that's what we've seen so far, right? Many people using different recall methods and approaches. So they said even though they were confident about their skills, they were somewhat scared of the grandmasters they were competing against. So they focused on recall methods from the start because they assume the grandmasters who are really good at this are much better at feature engineering. And their recall methods are deeply dependent on article embeddings. So these are based on image, text, word to vec, TF, IDF, and they'd use the Python package FAISS. So this is also something I'm seeing for the first time. To find similar articles and customers. For feature engineering, they didn't spend too much time, but using different day windows to create aggregated starts and customer article cross aggregated start features and different cosine similarities. For recall methods, those were composed of the following parts: customer's last bucket, user based collaborator filtering, item based collaborator filtering. To predict customers' next possible purchase articles and articles bought together. Also, popular articles with different attributes, like in a certain age group, this is popular, or in certain, based on the gender grouping, such items are popular. For embedding methods, he says that created article embedding from different methods. For article images, they'd use Swin transformer. So we're going down the leaderboard and seeing more and more sophisticated models. Sounds like the simplest one for images, at least. Mobile net was on the top. Then we got to efficient net. Now we're seeing Swin transformer. I'm sure we'll see GPT somewhere down there. I'm just kidding. But he'd used Swin transformer to extract the embedding features. Swin transformer, at least at the time of this competition, is a really strong model. So I assume that's why this was used. For the article text, he says we concatenated all text values and then use sentence transformer to extract the embeddings. It also uses article embeddings using TF-IDF. Most useful methods to get article embeddings are word to vec method, and for that they had used Gensim. They had also calibrated recall methods. He says it's better to use some method to calibrate all the methods, and he had used the method which was shared by him already. So here's the discussion where you can find the answer. But I think it's not worth highlighting. For feature engineering, they had used article features, which will be constant to all customers once you fix the observation time. Similarity and customer article features like cosine similarities between each pair, so on and so forth. For modeling, he says most of the time was spent with recall strategies. They only used LGBM for training and didn't even have time for other models. So their score is a single model score, which is absolutely incredible, right? Because I think this is the only team to have a gold with a single model. I think Guanshu also had a single model, but I'll post about that sometime later. So keep an eye out for that. Um, that's it for their solution. So all of their focus on the recall strategies, and we can see that they had used a lot of different approaches here: customer based, user based, item based, and word to vec based. So this was the fifth place solution. Um, I think I can also cover this one. So let's try to go through this. He says in this competition we were asked to recommend products. To solve this problem, our solution is split in two parts: recall and ranking. Good strategies used for generating candidates and feature engineering are both important to win a good place. So for recall, they did something similar to fifth place, where they had used they had created groups of user to item based collaborator filtering, user to tag item, and he says tag can be product code, product type number. So I assume they're grouping by based on all of this, and then they created hot items, which means popular items, I assume. For features, there were count based features. We've seen this a bunch of times while skipping. Gap based features. So for items first purchase time, it may represent the release time. And then they use gaps to calculate the preferences. Items discount using max or mean to represent the common price was another feature. They had used TF-IDF to set users' historical purchases to a sentence, and item simulation, I think that's what this is referring to. Collaborative filtering of item to item. And they had also set categorical features for department number and product type number. So they converted this to categorical columns, which gave them a small boost. They share the different models that given them the boost. So they'd use cat boost, light GPM throughout this, and either binary objective or lambda ranking. And they'd use about 100 or 200 candidates. For one light GPM model, they ended up using 1,000 candidates. Jiba, who's also a Kaggle legend, this is a part of. So he was a part of the team. Here's his solution. He says he had set around 10,000 article candidate list based on sales popularity in last 2 weeks, and then he built a data set with combination of customer ID into the 10,000 article IDs. From there, he had used a binary trained data set for the few weeks and trained model to select 200, 300, or 500 negative candidates. All of these were blended and best features based in popularity. Best features, I assume they're talking about what was the best features. were popular articles in a period or time passed since last purchase. There is also Jeeba's write up, which goes into more depth about this. So you can read through that. Again, this is just a very quick summary of Jeeba's approach in the team. I think the solutions after this are pretty straightforward. So maybe it might be worth wrapping up here. I'm just scrolling through to see if there's anything interesting. But no, based on what we've covered already, you're welcome to read through the remaining solutions. I'll be publishing Guanchu's solution sometime soon, so you can keep an eye out for that. Um, After this, I'll probably live stream something similar to the RSNA competition next weekend. So again, I'll keep live streaming every week, at least for the foreseeable future. And I'll of course live stream about a solution as soon as it ends. So that takes the priority. So either I talk about competitions that are similar to the ongoing ones, or talk about the ones that have just ended. If you have any requests for me to cover, leave a comment or just drop it in the chat. I'll look to it. But thanks for joining me again this weekend. I'll keep doing this every week. I'll see you next week, possibly learning about some image based medical competition. Um, and one more thing before I wrap up. Sorry, I wanted to point this out. Uh, the Devastator has summarized all of these solutions inside the auto competition, the top 10, I believe. And he says, happy 4 a.m. to you too. But if you want a very quick read, you can read this in under 5 minutes. He has summarized all of these inside the competition. So you're welcome to read through that if you like. All right. Alex says thanks, and that's my cue to wrap up. Thanks, everyone. I'll see you next week.